Hello and welcome to today's class. We're looking at the concept of electromagnetism. So let's discuss the concept behind electromagnetism in physics. By definition, electromagnetism is the study of electrical and magnetic phenomena. That's basically how you define electromagnetism. Having discussed about the concept behind electromagnetism, let's look at the concept of electrostatics. Let's look at the concept of electrostatics. Let's look at the concept of electrostatics. What definition behind electrostatics? Let's dive into the study of electrostatics, right? So by definition, electrostatic is a study of charge and charge system at rest. By the word electro, we mean charges. By the word static, we mean something being in a position or at rest. So combining them, so I'm saying that electrostatic is a study of charge and charge system at rest. That's basically how you define electrostatics. When it comes to the study of electrostatics, there are two laws that governs electrostatics. Let's look at the laws of electrostatics, please. Let's look at the laws, the laws of electrostatics. So I'm saying that when it comes to electrostatics, there are two distinct laws governing electrostatics. Let's look at the first law governing electrostatics. Number one, the first law states that like charges repel while unlike charges attract. First law of electrostatics states that like charges repel while unlike charges attract. That's basically the first law of electrostatics. Let me explain what law 1 means. So let's say I have a positive charge, right, and a positive charge, negative charge, positive and negative. Now I'm saying that law 1 says like charges repel while unlike charges attract. So I'm saying that let's say I have like charges, plus plus are like charges, minus minus are like charges. We said plus plus are proton, these are electron. So let's say I have two proton trying to combine. These two cannot combine, cannot attract. Why? Because they are what? Like charges. So like charges does not repel. So like charges repel, while unlike charges attract. So let's say I have positive, negative. These two can attract. Why? Because they are of opposite charges. So for something to combine together, they must be of what? Opposite charges. That's basically the idea behind the one that says that like charges repel, while unlike charges attract. That's the first law of electrostatics. We'll look at the second law much more later as we proceed. For now, let's spend law 2. For law 2, we're looking at much more calculation aspects when it comes to law 2. So let's spend law 2. Let's proceed to some other theoretical parts of this topic, and then later we'll look at law 2 much more later. So I'm saying that law 2 involves calculation. So look at calculation much more later. At this junction here, let's discuss method of charging a body. Let's look at the methods of charging a body. Let's look at the methods of charging a body. All right. So when it comes to method of charging a body, there are three distinct methods of charging a body. We have by friction, number two, we have by contact, and number three, we have by electrostatic induction. So let's say, so I'm saying that when it comes to method of charging a body, there are three methods there. The first one is called by friction. By friction. Number two is by contact, and number three is called by electrostatic induction. These are like the basic three method of charging a body: by friction, by contact, and by electrostatic induction. We'll look at these methods one after the other as we proceed. So let's start with the first one called by friction. What does charging a body by friction mean? So let's start with the first one, by friction. By friction. All right. Number one, let's explain about one. What does it mean to charge a body by friction? This involves charging a body by rubbing it against another body such that electrons are transferred from one body to another. So when it comes to by friction, a neutral body is rubbed with another body such that electrons are transferred from one body to another. So when it comes to by friction, it actually deals with rubbing. So a body will rub against another one so that electrical can transfer between the two of them. So from one to another. So I'm saying that when it comes to by friction, two bodies, one being neutral and the other being charged, they come together and they rub each other such that electrons are transferred from one body to another. That's basically how you define by friction. Now, when it comes to by friction, the simple example I can give you here when it comes to by friction is example under this example. The example here is rubbing a polythene strip with biro. This one example that is caused extensively on by friction. So by friction, we said it's one of the methods of charging a body, and the example there is rubbing a polythene sheet with biro. So I'm saying that go back to your younger age then. So during our time then, there's one thing we call magic, and neutrally it's not magic. It's the concept of by friction. Go back to your your primary one, primary two concept. When you were in primary or your younger school, observe that there's one time that we do tear sheet of paper, we tear a paper, and then we'll not take our biro, we'll not try to take the paper, like we'll place a paper. Let me show you the particular aspect of what I'm saying. Come on. All right, so let's say I have the paper placed this way. All right, a paper placed this way. So then we take a biro and then we will try to use a biro to pick the paper. Of course, the paper will not pick because they are neutral. So I'll have to charge the pen with my head this way. I'll charge this way. I'll rub it this way. I'll rub it. If you can remember, then we'll rub it this way, and then we'll now use it to pick the paper. And of course, the paper will lift up a little bit. That concept is by friction. So I'm rubbing a body against another So here's the concept. I'm trying to charge this one. If this one is charged, then definitely it can pick up this polythene, or we call it paper, 1 2. So when it comes by friction, you are simply rubbing a body against another body. That's basically the stuff. You can say that because I use marker. This is a marker. Try to use a pen and rub it very well. It will pick up. So I don't have a pen around me here. So that's basically how you explain the concept of by friction. Let's look at number 2 there, called by contact. By contact. Number 2, by contact. Definition. This involves charging a neutral body by bringing it close to a charged body without necessarily rubbing them together, as shown below. So I'm going to draw out a diagram for explaining by contact. But bear in mind that when it comes to by contact, I'm saying that this is the process of charging a neutral body by bringing it close to a charged body. Please, I'm not rubbing. When it comes to friction, I'm charging the body by rubbing it. When it comes to contact, I'm charging the body by what? Bringing it close to a charged body. I'm not rubbing, but what? I'm bringing it close to what there? A charged body. Example of this. So let's say I have. So let's say I have. So let's say I have a body. So I'm saying let's say I have a neutral body. I have a neutral body this way. Let's say I have a neutral body this way. Call this a neutral body. Neutral body. So a neutral body is placed this way. We said when it comes to by contact, you are placing a neutral body close to a charged body. So let's say I have a charged rod. Let's say I have a charged rod this way. Observe, I didn't rub them. I placed it, I brought it together like they are touching each other, right? So here's the concept. Here's the concept. If it's friction, if it's contact, they are both touching each other. That's the concept. But when it comes to by friction, you are rubbing. When it comes to by contact, you're not rubbing. You're just bringing the two of them close to each other, as shown below. So let's say I have a negative charge this way. So this rod here is a negative charge rod. I'm bringing it close to a neutral body. What do you expect? The negativity will display into the neutral body, right? So I'm saying that in my end product, let's say I have this diagram A. For diagram B now, I'll be having something of this nature such that the negative charge rod is being. So let's say I want to take off the negative charge rod. What will be left here? Of course, I'll be having what? A negative charge. So this board now becomes a. So this body now becomes what a negatively charged body. Why? Because I placed a negative charge rod close to a neutral body. So it is neutral. So the negativity will be transmitted into the neutral body, such that I'll be having something of this nature. So this becomes now a negative charged body. So this becomes a negatively charged body. So this becomes a negatively charged body. That's like the concept behind by contact. So when it comes to by contact, I'm not rubbing. I'm just bringing it close to a charged body, as shown below. That's basically how you define by contact. Let's look at by electrostatic induction. Number 3, by electrostatic induction. By electrostatic induction. Definition, please. All right, let's explain by electrostatic induction. Electrostatic induction involves charging a neutral body by placing it close to a charged body without any necessary kind of contact between the two bodies. Now, I'm saying this, please. Listen. when it comes to friction and contact, the two bodies are in contact. That is, by friction can be taking place when the two bodies meet. By contact can be taking place when the two bodies meet. But by electrostatic induction, the body does not have to meet each other, right? So I'm saying that I'm charging a body against another body by bringing it close to, I'm bringing it close to, not in contact to. So I'm bringing it close to what? A charged body, right? So let's use a diagram to explain electrostatic induction, please. All right, let's explain by electrostatic induction. So I'm saying this, please. When it comes to by friction and by contact, we said the two bodies are touching each other. So either by friction or by contact, the two bodies are touching each other. But by friction involves rubbing, by contact involves bringing it close to, or perhaps bringing it in contact to a neutral body. So bringing a charged body in contact to a neutral body. But when it comes to by electrostatic induction, there I'm bringing a body close to a neutral body. So I'm bringing a charged body close to a neutral body, right? Without any necessary rubbing. So I'm not rubbing anything. I'm just bringing it close to. Let me just show you what I'm trying to say here in a direct expression. So let's say I have a neutral body this way, diagram A. Let's explain this. Let's say I have a neutral body. I call this a neutral body. Neutral body, right? As my diagram A. So let's say I want to bring in a negative charge rod close to this neutral body. So let's say I have a rod this way. Please, when it comes to by electrostatic induction, we said the rod is brought close to, is not brought in contact to. Please mind the language, please. It's brought close to a neutral body. So I have my neutral body this way. I have this my neutral body this way, right? So next task there. Let's say I have a negative charge rod here. Negativity, negative, negative, negative. These are electrons, right? Now listen, we said this man here is a neutral body. Please, if an element or a substance is neutral, what does it mean? It means it has equal number of protons and electrons. Now listen, please. Let's explain this. When it comes to neutral concept, here is how I try to explain to students. So let's say I have, let's say I have diagram A, diagram B, diagram C, this way. So let's say I have plus, plus, minus, 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 plus, 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 minus, minus, equal number of plus, equal number of electrons. So look at this, please. Look at this, please. Here's the concept. Positive are called proton, negative are called what? The electron. Now plus will cancel minus, plus will cancel minus. This body here is a what? It's a negative charge body. But it being negative does not mean that it does not have what? The proton. So this is an electron. This is a negative charge rod. It being negative doesn't mean that it does not have what? The a proton. It has, but what? It has little number of proton. For B, let's say this cancel this, this cancel this. This is what? Positively charged is a proton. It being proton does not mean what? It doesn't have what? The electron. It has electron, but what? The a less number of what? Electron. For this one here, this cancel this, this cancel this, this cancel this. Diagram C. Oh, come on, I don't have any proton here or any electron here. But here's the concept. They have little number of proton and electron here. So here's the concept. For a neutral body, there are equal number of what? Proton and what? Electron. So here, in this case now, I'll be having positive charge this way and negative charge this way. Positive charge here, negative charge in this place. Now, here's the concept, please. Here's the concept. I just tried to explain positive and negative charge for you, intra body, right? So that's by the way. Now look up, please. So let's say I have, so I'm trying to explain in electrostatic induction. So I have placed a negative charge rod close to what? A neutral body. And I said a neutral body will have positive and negative charge in it, right? So it being neutral means it will have equal number of proton and what the electron, right? Now here's the concept, please. Why is it that I place positive charge close to negative charge rod? Why is it that I didn't place negative charge up here? Why did I place positive charge here? It's intentional from your law 1 of electrostatics rules. So your law 1 says that. So this principle actually work in accordance to your first law of electrostatics that says that what light charges repel while unlike charges attract. So it means that this negative charge rod will be attracted by the what? The positive of this neutral body. So this and this will attract. Why this one there? This negative charge will repel. Now for the diagram C of this concept, for diagram C, of course, if they have attracted this way, I'll be left with what? Negative charge body, right? So I'll be left with negative charge body. So I'll have something of this nature. So I'll now apply one principle called earthing. So I'll apply a principle called earthing. So here's the concept. I'll be having, of course, negative charge rod. Positive will be here because they are attracting. Negative will be here. So now here's the concept. This negative charge here will be transmitted to the ground. So by using what? A conductor. This is conductor. A conductor, right? So I'll apply the principle of earthing. This symbol for earthing. So earthing is simply a process of transferring a left charge or unused charge to the ground surface, right? So I'll apply the principle of earthing. So I'll use this left this left electron here will be transferred to the ground such that I'll be left what there? I'll be left with a neutral body. So here's the concept now. So after transferring this electron to the ground surface this way, so this I said this is called earthing. Is called earthing, a process of transferring unused electron to the ground. It's called earthing. So I'll transfer this unused one to the ground so that I'll be left with what the positive charge body. So I'll be left with this electron, positive charge electron this way. So here's the concept. I converted a neutral body to what? A positive charge body. How? By passing through electrostatic induction. So we said neutral body, a rod is being placed close to it this way. We expect that a neutral body has equal number of proton and what? Electron. So the proton and electron will attract because they are opposite charge. They will attract. Why this one what they will repel? So this one being repelling will have to move to the ground because it's useless, it's not unused. So I'll now use the concept of earthing to transfer this one unused to the what? To the ground. And that process is called what? The process of transferring unused to the ground is called the earthing. So I will earth the part that is not of use to the ground, and then I've left what there? A positive charge body. This is like the explanation I can give to the concept of electrostatic induction. So diagram A, B, C, and D. A, B, C, and D. All right. So let me just try to give you a basic note to all this concept here. So let's take a quick note under this. So I've given you definition to electrostatic induction, and I explained this. So let me just try to give you a basic note on diagram A, B, C, and D, please. Now, after the definition of this, I've given definition. So under definition, leave a line, one line space paragraph. So step one, please. Step one. Put on, please. Step one. The neutral body is given in diagram A below. Step one. Please, after defining definition, leave a line, one line space paragraph. Don't write step one. For your step one there, I said the neutral body is given in diagram A below. So what I said, copy it down and then draw diagram A, please. I said neutral body is given in diagram A below. As you can see, draw this one out. Step 2, under this place. Step 2, a negatively charged rod is brought close to a neutral body without any contact, such that the positively charged move towards the negatively charged rod and the negativity charge moves against the negatively charged body in accordance to the first law of electrostatics as shown below. Draw this man, please. As shown below, draw this diagram, please. Diagram B. Step 3, at the part of the neutral body having the negative charge charged such that they flow into the earth as shown in diagram C. As shown in diagram C. So at the part of the neutral body having negative charges perhaps such that they flow into the earth as shown in diagram C. Draw this diagram out, please. Diagram C out, please. Step 4, please. Step 4. Take off the negative charge rod. Take off negative charge rod and the conductor such that the neutral body becomes positively charged as shown in diagram D. As shown in diagram D. So I have this concept here. So these are the explanation to electrostatic induction. So let's look at the concept of conductor, semiconductor, insulator, and superconductor. Let's look at the concept of conductor, insulator, semiconductor, and superconductor. Let's look at the concept of conductor, semiconductor, insulator, and superconductor. Let's discuss these thoughts one after the other. So what's a conductor, what is semiconductor, insulator, and superconductor? Let's have the first one called conductor. Let's explain what conductor is. What's a conductor? Put on, please. A conductor are material that allows the flow of electrical charges. A conductor are material that allows the flow of electrical charges. So I'm saying that a conductor are materials that allows the flow of electrical charges. Example include copper, iron, and etc. Right? So that's conductor. Number 2, let's discuss insulator. What are insulator? Please put down, please. These are material that does not allow the free flow of electrical charges. These are material that does not allow the flow of electrical charges. Example include dry wood, and etc. That's insulator. Let's look at number 3 there. Let's look at the semiconductor. All right. Definition. These are material which in their pure state do not conduct electricity, but become superconductor when impurity are added to them through a process called doping. Example of semiconductor include, let's say, silicon. Silicon is an example of a semiconductor. Number 4, let's look at the superconductor. The superconductor. All right. For a superconductor, please put on, please. These are material that does not have any form of resistance to the flow or passage or the movement of electrical charges. Example of a superconductor include germanium. Germanium is an example of a superconductor. Semiconductor, silicon is an example of a semiconductor. Dry wood is an example of what? Insulator. Copper, iron are example of conductor. Alright, these are like the concept behind conductor, insulator, semiconductor, and a superconductor. Let's look at one last concept and I'll hop with this, please. Let's look at the concept of charge quantization. Charge quantization. Let's look at the concept of charge quantization. Definition, please. Charge quantization means that charges cannot take any arbitrary value, but only value that are integral multiple of the functional charges. Charge quantization means that charges cannot take any arbitrary value, but only values that are integral multiple of the functional charges. That's the definition of the charge quantization. Mathematically, charge quantization is represented with a capital Q. Capital Q is equal to plus or minus NE. This is the formula for calculating charge quantization. Q is equal to plus or minus NE. Let's define parameter, please. Let's define parameter where Q is called charge acquired in coulombs, right? In bracket C. What does N mean? N means number of charge or charges, or number of electron transferred. Number of electron transferred. What's E? E means charge of an electron. So E means the charge of an electron and has a constant value. The value for E is given as 1.602 times 10 to power minus 19 coulomb. Alright, so bear in mind that E is known as charge of an electron. It has a value, a constant value, 1.602 times 10 to power minus 19 coulomb. So this is like the concept behind charge quantization. Q equal to plus or minus NE. So the plus or minus depend on your usage, right? So I will explain this concept when we take an example. So let's look at example 1 involved in the study of charge quantization. Example 1. Let's take a sample problem under the concept of charge quantization, and then we'll hope, please. Let's look at charge quantization. All right. Example 1, please. A plastic rod is rubbed against a wood sheet, thereby acquiring a charge of minus 0.2 microcoulomb. Full stop. How many electrons are transferred from the wood sheet to the plastic? So that's like the example to number 1. That's example 1 under charge quantization. Example 1. So please, first things first, after reading out the question, list out parameters, please. It says a plastic rod is rubbed against a wood sheet, no problem, thereby acquiring a charge. So I'm giving a charge. What's charge there? So listen, it said thereby acquiring a charge. Charge acquired is what? Is Q. So capital Q is given. A charge of what? Minus 0.8 microcoulomb. Proceeding. How many electrons, please? Number of electrons. So number of electrons means how many electrons? That's N. So N is unknown. How many electrons is unknown? How many electrons are transferred from the wood sheet to the plastic? So we don't know yet. We said that E is a constant value, which is what? 1.602 times 10 to the power minus 19 coulomb, right? We said it's a constant value. Let's get N. It's easy as we said. Recall that we established that charge quantization, capital Q, is equal to NE. I'm looking for N. It's easy as what? Divided by E, divided by E. This E will cancel this. So I'm having that N is equal to capital Q over E. Put in your values. Capital Q is of course a negative 0.8. Micro is a constant value, that's 10 to the power minus 6. That's micro. Then I have the coulombs, 1, 2. So all over E. What's E? E is called charge of an electron. The constant value, that's what? 1.602 times 10 to the power minus 19. All right, this is the value for. So dividing the 2, I should have about. Dividing the 2, I should have about. So my N, that's number of electron transferred, should be equal to 5 times 10 to the power minus 5 times 10 to the power 12. Now listen please. I said when it comes to plus or minus, it depends on your usage. Now I'm asked to find number of electron transferred. Some things can never be negative in life. Yes, something cannot be negative in life. Example, if I ask you that in this class now, how many boys are here in the class? Because if you tell me minus 5, it's incorrect. If I ask to measure what's the length of this board from here to here, what's the length? You told me minus 10 meter. It's not proper. So something can never be negative in life. So I'm saying that number of something cannot be negative. Number of something cannot be what the negative. So I'm saying how many number of electrons can be transferred? You're telling me minus 5 electrons can be transferred. So this is not possible. So now I know that number of something cannot be negative, and I have a negative sign here. I'll now have to bring up what? The concept of plus and minus here. What do we know? This Q has negative on it from its question, originally from the question. So for me to cancel this negative here, to make this answer positive here, I have to introduce what? One of the two. So the best one to introduce here to ensure that I have a positive answer here is what? I'll bring up the minus. So minus sign here. Minus sign will give us a plus sign. So this becomes what? The answer to this question. Please, I'm saying this and I'll repeat again. I'm saying that plus or minus depend on usage. So I'm asked to find number of electrons transferred. So number of something cannot be negative. So although the Q came negative sign, but yet I have not used this one given. So that's the concept now. Which one will I place? will I place under this that will give me a positive charge? That will be what the minus. Minus divided by minus will give me what? Positive. So 5 to 6 power minus 10 to power 12. So that's like the answer to that particular question, right? So that's like the answer to this question. These are you solve problems involved in charge quantization. So next class, we'll look at the second law of electrostatics called the Coulomb's law of electrostatics. So look at Coulomb's law of electrostatics. We'll look at the vectorial form of writing Coulomb's law in the next class. And we'll look at linear charge configuration, triangular charge configuration. We look at circular charge configuration, semicircular charge configuration, rectangular charge configuration, and also square charge configuration in our next class. All right, see you next class, and welcome to Excellent Link Academy. I just launched my website. To get more of interesting courses like this, you can visit www.ganiyu.com. My website, you can buy the courses there and have a lifetime access to those videos. Also, I just launched a book called The Shortcut to Success. So buy this book. It costs about 2,000 naira. If you're interested in the book, I'll drop a link to my description of this video. Click on the link and pay for the book, and then you have access to the book. All right, see you guys in the next class, and welcome to Excellent Link Academy.